To ask ourselves what an acid is or what a base is, we first have to go back a little bit and remember some of the important properties of water. Ice floats, it has a high heat capacity, surface tension, cohesion, adhesion, but most importantly, water acts as the universal solvent. Chemicals dissolve readily in water. In particular, chemicals held together by ionic bonds. With that in our head, let's go back to this question. What is an acid? What is a base? The definition of an acid-base is simple. Acids are chemicals that are proton donors, or H plus donors. Bases are chemicals that are either defined as hydroxide ion, OH minus donors, or proton H plus acceptors. There really isn't anything new to learn here about what a proton donor or hydroxide ion donor is. We simply have to go back to our understanding of atomic structure and how atoms form ionic bonds. On the left, we have a hydrogen atom. On the right, we have a chlorine atom. And we should remember that when I put these atoms together, chlorine with 7 electrons in its valence shell, and hydrogen with 1 electron in its innermost shell, which is also its valence shell, the hydrogen atom is going to donate its 1 electron to the chlorine atom. When we do that, hydrogen really is nothing more than a proton. So we could either call it a proton or H plus. Since it lost its electron, it only has the one charged particle. Chlorine is an ion too as well, because now it has one more electron than it does proton. And when I write these out on a piece of paper, I would usually write hydrogen as H plus and chlorine as Cl minus. And we know because these two ions have opposite charges, they're going to be held together by an ionic bond. When I put compounds held together by an ionic bond in water, the polar nature of the water molecule, being slightly negative on one side and slightly positive on the other side, attacks the positive and the negative ions in the ionic bond. So they disassociate. So as soon as I put this HCl, or what was hydrochloric acid, in water, the two ions dissociate, separate, and I now have H plus dissolved in the water. This, H plus, the proton, is what an acid is, simply put. So you can imagine that the more HCl I put in water, the more molecules are going to disassociate because they're held together by ionic bonds, and the more H pluses or protons I have in the water. As I get more and more H pluses, I become more and more acidic. So the next question is, how do I measure how acidic, or on the other side of the coin, how basic something is? Well, I use something called the pH scale. And the pH scale is a measurement of essentially the amount of protons, H plus, or hydroxide ions, OH minus. If I have pure water that is 100% H2O, nothing but this molecule right here, one oxygen and two hydrogens covalently bond to it, every now and then I'm going to get one of these protons kind of deciding to go off and do its own thing. It leaves behind its electrons with the oxygen in this molecule because it's required for this molecule to have a full valence shell. This proton is perfectly happy not having a valence shell. And now if I do a little math, okay, I've got one proton, 0 electrons. I'm going to have a charge of +1. Over here in the OH molecule, I have 9 protons, 10 electrons. I'm going to have a charge of -1. And now I have those two molecules that we discussed when we talked about the definition of what an acid is, H plus and OH minus. When I have 100% absolutely pure water, the molecules fall apart every now and again. It happens. But every time they do, I get one H plus and one OH minus. The H plus That's what an acid is. The OH minus, that's what a base is. So when I look at the pH scale, it goes from 0 to 14, with the middle or neutral being 7. And that 7 is when the concentration of OH minus is equal to the concentration of H plus. And we're neutral. We're not acidic or basic. When I get less than 7 on the pH scale, that happens because I have more H plus present and I'm acidic. When I get greater than 7 on the pH scale, it occurs because I have more OH minus present and I become basic. Sometimes we refer to bases as hydrogen acceptors. If you think about it, if I've got more OH minus, it can essentially interact with H plus to form H2O, water, getting rid of the H plus. Just for reference, normal rain has a pH of about 6.5, so it's just slightly acidic, whereas human blood has a pH of about 7.3, just slightly basic. Tomatoes have a pH of around 4, and lemons have a pH of around 2, whereas household ammonia has a pH of about 11, and oven cleaner a pH around 13. So now that we have a feel for what the pH scale looks like, less than 7 being acidic, more than 7 being basic, and 7 being neutral, and a feel for tomato juice versus normal rain versus household ammonia, the next question is, well, just how much more acidic is something that is, let's say, at a pH of 3 than something at a pH of 6? The pH scale is a logarithmic scale. This means that every step on the pH scale is a factor of 10, or multiplied by 10. So when I go from a pH of 6 to a pH of 5, I'm 10 times more acidic. If I go from a pH of 5 to a pH of 4, again I'm 10 times more acidic. So if I went from a pH of 6 to a pH of 4, I would be 10, not plus 10, 10 times 10. So 10 times 100 times more acidic. Let's say I go from a pH of 6 to 5 to 4 to 3. That means I made 1, 2, 3 jumps on the pH scale, and I'm 10 times 10 times 10 more acidic, or 1,000 times more acidic. A pH of 3 is 1,000 more times acidic than a pH of 6. Pretty staggering. What if I go one step farther, and instead of going from 6 to 3, go from 6 to 2? Well, I multiply by 10 again, and I wind up being 1,000 times more acidic. So while you might hear the pH of lemon juice at 2 and the pH of tomato juice at 4, and you think, well, 2 is not that much more acidic than 4, it's 1,000 times more acidic than 4. And if you think the pH of blood is slightly basic, around 7, and the pH of lemon juice is around 2, well, is it really that more acidic? 10, 100, 1,000, 10,000, 100,000 times more acidic.